You are probably familiar with petroleum's energy efficiency and our primary source of electrical energy, efficient energy from nuclear power plants. Therefore, I will cover all alternative energy sources in the context of energy efficiency. These sources are wood fuel, biomass fuels, synthetic fuels, geothermal energy, fusion energy, and two other unexpected energy sources. Wood was humankind's first energy source. At abundant tree sources thousands of years in the past, our ancestors cut down trees for the heating fuel. Of course, our ancestors needed to first invent fire to burn this wood. Since that long ago era, we have made more use of wood. Currently, we produce paper from wood pulp. Although wood supplies are huge, they are not inexhaustible. We must not lax from the responsibility of planting 2 trees for every one we cut down. Considering the aforementioned, and because trees absorb a significant greenhouse gas, CO2, we should avoid exploiting them further. Biomass fuel production is currently ongoing. Refiners produce this fuel using popular willow and feed grass from idled farmlands. This fuel source is non-polluting, but inefficient due to high production expenses. Nonetheless, you may be using biodiesel in your automobile or pickup truck. Synthetic fuels are gaseous and liquid fuels that manufacturers can produce from coal, shale, and tar sands. Although these fuels can reduce petroleum consumption, and thereby greenhouse gas emissions, they are too expensive to produce commercially on a large scale. Geothermal energy is electricity production using the Earth's internal temperatures. Although mainly non-polluting, geothermal power plants' sulfur emissions are only a few percent of those from fossil fuel alternatives. To make efficient use of this alternative energy, companies would need to dig deeper and deeper towards the Earth's core. These actions could possibly cause disastrous sinkholes. Fusion energy is what our sun produces. However, in this context, I'm referring to placing fusion reactors on the Earth. Although non-polluting in the forms of greenhouse emissions, we would have radiation problems. You could get severe radiation burns if your fusion refrigerator malfunctioned. The question is moot though. Scientists have not produced any working models for fusion energy. Since this article's subtopic is the cost of energy efficiency, I may as well mention 2 energy sources that appear in many science fiction stories: anti-gravity and antimatter. Science know that both types exist. If you think of zero-G, you know that it is a form of anti-gravity. The major problem with anti-gravity is that there is no known way to control it to produce electrical energy. You can experience zero-G by doing certain tumbling maneuver or flying in a high-flying aircraft. Astronauts train using this method. However, until humankind finds a reliable, natural or artificial source for anti-gravity, we cannot determine the cost of its energy efficiency. Antimatter means that you would be dealing with the subatomic world. In addition, antimatter does not exist naturally, as far as we know, in huge amounts that we can use efficiently. If you went into interstellar and or intergalactic space, you may find planetary-sized antimatter deposits. In such circumstances, you could become the richest man or woman in human history. From the research that scientists have done with this form of energy, or maybe this is also science fiction, it appears that antimatter would create enormous radiation problems.